Hi, hello everyone. Thank you for coming here on this last track of the last day. I think we have good attendance for that. I'm here to present this paper, exactly the challenges of bringing cryptography from research papers to products. So let's have a look at that. Academic incentive structures do not reward real-world impact of cryptography work. Now, isn't that an interesting statement to debate, right? If you want, feel free to churn that over in the back of your head for the rest of this talk. We're always happy to hear any insights, opinions, especially hot takes from experts like you. Come back to us. This is meant as a teaser. It will make sense in a minute. Let's talk about the paper. What did we set out to do? Our research goal. To explain it, I want to first explain this term we use throughout the paper, cryptography adoption. It's a term we use in the paper. I want to use it here. So we've been wondering. We have all these awesome cryptographers in our community, right? Awesome people doing cryptography research, putting ideas into papers, publishing them. And then on the other hand, in the real world, we have cryptography that is used by some app on some end user's iPhone. And this question of cryptography adoption basically is, how does this end up there, right? How does cryptography research end up in real world products, right? So the goal of this project was to investigate this process of cryptography adoption. Okay, how did we do that? I cut this part really short. Basically, in the end, we had 21 interviews with cryptography experts. Those were really in-depth interviews, about 90 minutes each. And our experts had backgrounds in academia, industry, nonprofit, and governmental organizations. All of them had at least 10 years of experiences. Most of them had much more. The average was above 23 years. All of them were multi-experts with experience across multiple cryptography domains. I'll talk about those in a minute, and also across multiple of these backgrounds listed up there. Okay, and then we conducted thematic analysis on the interview transcripts. Cool. What did we find? So the first question we wanted to answer was, what are the steps that are involved in this cryptography adoptions? Who might be relevant actors, stakeholders? So you might think that this could be a really easy 1-2-step process, right? You read a cool crypto paper and this inspires you to go out, write some code, have this used by someone. Well, actually, in reality, it might look a little more like this. So stay with me. Don't be overwhelmed. We'll go through this step by step. Right, so this is supposed to be a visualization of the cryptography ecosystem that helps us to describe this path that cryptography adoption can take. Okay, so we have these stick figures, and they are supposed to represent actors or roles in the ecosystem that people can take on. And we have the rectangles. They represent artifacts or products that are either created by people or can be chosen and used by people. All right, we'll go through this map from left to right. Right, left is theory, right is real world. So on the very left, we have this role of cryptographic designers, right? So people coming up with cool algorithms, protocols, and putting those into papers, right? Maybe even accompanied by some like proof of concept code, publishing those papers. Then we move on to the role of applied cryptographers, right? So these take the theory work and actually implement it, right? Maybe in the form of some secure implementation, like a cryptography library. That then can be used by others. There's also standardization efforts going on where cryptographers can sit down with industry stakeholders and try to agree on some cool, secure crypto standards. And these standards might even get a stamp of approval by organizations like NIST or IETF, right? Cool. Moving on further, we have actual product design, so software development, hardware development. This could be like your everyday developer who doesn't know much about security, and they are tasked with implementing some security feature into the product that their company is building, and then they can just go and grab some nice secure implementation to solve the problem and have it in some real-world product. And then at the very end, we have end users, right? Private end users or organizational end users who choose and use these products with cryptography in them. Right. So easy peasy, we have this really beautiful path of cryptography adoption, right, from left to right. And there is absolutely nothing that could ever go wrong on this path, right? Right? Okay. So we had another research question that we looked at in the paper. What can go wrong on this nice path of cryptography adoption, right? What are key obstacles hindering the widespread adoption and correct use of cryptography? And we did some, like I said, some thematic analysis. And one of the things that came out of that were these 5 overarching themes that describe like meta cryptography adoption blockers, right? They're listed here. And what I want to do now is just show you some example quotes from our interview to illustrate and highlight some of these themes. There's much more in the paper. This is just a very, very light selection. Okay, we'll start out with a simple one. Practical impact does not get you papers at crypto, right? This is what someone said in the interview. And yeah, there are definitely conferences who reward direct real-world impact less than others, right? And this is okay. This doesn't have to be a bad thing, right? We just note for this project that, yeah, some conferences might be inherently just misaligned with our proclaimed goal of cryptography adoption, right? Good. Next quote on standardization. People won't get much academic credit for spending 3 years flying to IETF meetings and fine-tuning a standard. So maybe there is an academic incentive problem, right? Follow up with another one. Standardization is very, very painful. There are academics who do that. Some in IETF, they are doing it because they feel it's a socially important thing out of some kind of social duty. But it's difficult to find these folks, right? So this underlines, one, that there might not even be many people who have the skills to do this standardization work in a good way, especially in academia. And then 2, there often might not be any materialistic incentives for academics to put like years of work into standards drafting when you could also instead use that same time and resources to just create and publish lots of papers on like conferences. Good. Switching to a different topic, the importance of reference implementations, right? If you're a cryptographer, you write a paper, and if you really want people to use your crypto, you have to have code that they can use to play with. That is what academics don't do enough. It has to be a piece of code that is genuine enough that it can be used to do stuff that is not just what you have said in the paper, but more general use. So this one underlines the importance of making it as easy as possible for other people to pick up your ideas, pick up the code, and play with it. And it also implies that there might, again, be missing incentives for academics to go this extra mile and supply the most like usable code together with your research output. Okay, still on the same topic, reference implementations, the quality of these implementations is very, very variable because the skill set of making an implementation is different from the skill set of writing a paper that is accepted at some crypto conferences, right? So this says it's not that cryptographers are lazy or something, right? Implementation, like good reference implementations require skills in things like secure coding and even usability. Okay, last one because it's really fun. So we talked to this researcher and they said, I at some point tried to install Project Everest. Project Everest is this suite of tools for formal verification of cryptographic software, right? So they said, I at some point tried to install this project and a fellow researcher told me, here's the script, you download that script, you run it, and either that just installs everything and everything works, or you are in big, big trouble. So I was in big, big trouble. I spent the whole weekend actually not installing Project Everest, right? So we have these highly skilled people wasting their valuable time and just trying to set up some tooling to check out some other researchers' output. Yeah, blockers to cryptography adoption. Okay, so much for the quotes. Let's move on to the last question we addressed in our paper. And this is what are potential ways to overcome these obstacles, right? Because we want to be helpful to our much appreciated cryptographer friends in the community, and we want to see more of their cool ideas out in the real world. Cool, so we grouped this, we deducted some recommendations for different groups. One of the groups we have recommendations for is like academia, of course, right? So cryptographers who are interested in adoption of their output can consider 1, going the extra mile, provide accessible, usable reference implementations of their work, and then also reaching out to experts in other domains like secure software design and usability. Additionally, we would love to see some tweaks in academic reward structures to account more for 1, the participation in standardization efforts, and then also for secure, usable, production-ready implementations of cryptography. Right. There's much more recommendations in the paper. This is just a small selection. Okay, recommendations for more industry-side people. We encourage companies and organizations to consider investing in core infrastructure maintenance projects, like the Open Source Security Foundation. We also encourage implementers and users to reach out upstream, communicate problems, actively contribute to open standard development, instead of doing everything behind closed doors. Last set of recommendations towards standard organizations this time. Our results imply issues with the complexity, readability, and actionability of standards. We'd like to consider employing methods from usable security research, like user studies, to improve, 1, the standards, and then also the standardization processes themselves. And yeah, standardization organizations should make sure they are trustworthy by further engaging with the academic community, emphasizing open communication. We love open competitions because this seal of approval of a trusted standardization organization is a major driver for cryptography adoption, of course. All right, that's it. This is just a summary slide. I hope I was able to spike your interest in our paper. There's much more analysis, quotes, recommendations in it. Don't hesitate to reach out with any ideas, feedback, or questions. Thank you so much.